We formed BAC, myself and my brother, back in 2009, but we actually started the design project for the car we wanted to create in 2007. We launched it in 2011, and I'll explain a little bit about how that process went. But designing a vehicle, and I say vehicle rather than car, designing a vehicle like Mono has many challenges and many opportunities. The challenge is it's a very low volume vehicle. We're a small company. The opportunities are derived from that. It allows us to do certain things that the bigger companies can't do. So we tried to take our disadvantages of being small and turn them into advantages. But before I show you kind of how we deal with these different aspects of designing and developing the product, I need to just put the product into context for you. So you're going to see some pictures you probably didn't expect to see today, that being one of them. So just bear with me on this. This is a small intro just to understand the product. So there was a time when the horse was transport, and it was the way we got around, it was the way we worked in fields, it's the way we delivered things. When you made choices about which horse you wanted to buy, you had to consider many, many factors, and so you had to try and find an all-rounder. Of course, what happened was the car replaced the horse as transport, and as such, it did a better job than the horse. Why did it do a better job? Well, it took you from your own door to your destination in your own personal space. We'll come back to that in a minute. But what happened to the horse? Well, horse riding became a leisure activity. It was no longer transport, and as such, you no longer needed to make decisions about is it good at all these different functions. But now you're able to make horses choose a horse based on how would I like to use the horse. So obviously the agility, the speed, the athleticism of the different types of horse riding lead to different kinds of choices. So I think bringing it into something a bit more relevant for transport, this is a modern bicycle. It has things like mud guards. It has places to store luggage. Very often today, it will have be electric powered, built-in locks, things like that, and it serves the transport function really well. But this is what bicycling is for most people nowadays. And you can see here, if you look closely at these two bicycles, they're very much optimized at exactly the type of use, the leisure activity that the rider wants to participate in. The first one's a time trial bike. It's very much based on ergonomics. It's very much based on low drag, low weight. It's very much optimized for that. The other bike, it's just as optimized, but it's optimized for a completely different function. It's optimized to take large impacts like you see the crazy guy on the right about to take, and you end up with very, very different products, but still very much derived from transport, and now transport as a leisure activity. Is it possible to turn this mic down? I'm getting a really bad echo. Thanks. You see this everywhere in transport. Things that were originally transport, crossing frozen lakes, crossing deep snow was originally the purpose of a ski. But now today, for most people, most of the time, skiing is a leisure activity. You have exactly the same situation with sailing. Again, sailing was a pastime. It's become a pastime, but in the past it was transport. It was the way we crossed the globe. And now it's got to the point where sailing, for most people, most of the time, is a leisure activity. And as it becomes a leisure activity, it develops further. It becomes a sport. And of course, you end up with situations like this, where this sailboat has been optimized to the extent that it's absolutely designed around a set of rules, and it's absolutely optimized for, in the case of the America's Cup, for the location that they're in. So that's how transport has developed in many ways and led to leisure activity. And so we see at BAC, we see that the car is going to continue to be the primary mode of transport, and it's going to optimize, it's going to get better at that. But we also see a divergence. We see that driving is going to become a leisure activity for certain people. Just briefly over the future of the car. As I said before, it's convenient door-to-door transport in your own personal space. Everything that happens with the car will be built upon that. And it's as well to remember that the success of the car is nothing to do with the fact that you actually drove it yourself. Yes, people derive pleasure from driving, sometimes, some people, but that isn't why the car was successful. The car will continue to be successful because it will become autonomous. Wealthy people have for years had a chauffeur, and we see that we'll all be able to have a chauffeur eventually. Electric, I think there's no debate about that being the future. We're convinced that the electric motor will drive the driven wheels. Quite whether it's batteries, fuel cell, and all the other different ways of having that electricity on board, there's some debate there, obviously. Something else that I personally and we at BAC are convinced about, eventually, we don't own trains, we don't own aeroplanes, not many of us do anyway, ships. When it becomes purely transport, we don't need to own it anymore. And if I just want to go on a short journey, I can call up an app. They have a system in Germany at the moment called Car2Go, electric smart cars. You call it up on your app, you can get in it, you pay 29 cents a minute, and after 2 or 3 minutes, you get to your destination, you park it for free. Well, that's perfect transport. When that can drive to me, pick me up and take me to the restaurant and drop me off, that will be fantastic. Of course, there's other occasions where I might want to go on a bit more of a special occasion, so I might want a Mercedes S-Class to pick me up and not a smart car. And so I can optimize my journey every time by calling up the vehicle I need in the app. So if that's the future of transport, that's the future of the car as transport, we at BAC, like I said earlier, are starting to focus more on what will be the future of the car for the people who enjoy driving, the people who ended up horse riding when the horse was replaced by the car, the people who ski, the people who sail, the people for whom it becomes a leisure activity. So we'll come back to this later. It'll be more relevant later, but just roughly, this is all about transport on this end of the graph, and at the other end, it's a focus on performance, a focus on driving. So just the obviously there's no focus on performance or driving in a London bus. It's literally just transport, and a Formula One car top right, there is no transport function. So that just gives you the field in which we kind of will move later on. So I don't know how many people know the car, but this is the car we launched in 2011. We call it Mono for obvious reasons. It's a single-seater. And from 2011 till 2019, we iterated the car, we optimized it, continued to improve it, which I'll come to shortly, until in 2019 we launched this car. This is Mono R, this is the current production car, 555 kilos, 355 horsepower, all carbon. And again, I'll come to some of the details as we move on. But what's it for? It's for adventure. It's for the person who enjoys driving as a leisure activity. He takes a pride in driving. He finds driving rewarding. He wants to get better at driving, just like people who go skiing, just like people who go cycling. Obviously, it's very, very high performance, and any high performance cars, it's most at home on track. But that isn't only what it's about. It's about driving as a leisure activity. I like this picture because as a guy out on his bicycle, on his road bike, he's wearing his Lycra, his aerodynamic helmet. He's optimized doing his sport, and one of our owners is in the same place. This is Northern Italy, out doing his sport, and that's really what Mono's about. That's why I prefer not to call it a car. It's almost like a four-wheel motorcycle. We always struggle to find the right way to describe the product, but it's nothing to do with transport. That's the point. What that allows you to do, this specialized function of the product brings a focus. It allows you to focus down on what's going to make it the best product, and this is where I can explain a bit more about how the product's created. So if we're free of the transportation function, we can obviously get rid of a passenger seat. We can optimize the weight of the vehicle. The driver sits directly in the middle. Behind him is the engine, which is a structural component. Behind the engine is the gearbox. Between the engine and driver is the fuel tank, and by putting it there, we again centralize the mass, and between full and empty tanks, we don't have any change of center of gravity, so we can keep our 52 to 42 weight distribution. We focus on a really low center of gravity. Again, I'll come to that shortly. But you see things like the cooling system, we can put the radiators directly next to the engine. We don't want to send water all the way to the front of the car and all the way back again. It's just going to, it's just fluid you're having to carry. It's litres of liquid that we don't want to have to carry. The other thing, as you can see here, you get really nice long suspension. You get great kinematic. You can really control the wheel movement. Again, mass concentrated in the centre. So once we've created a package where we're completely focused on optimizing that package, it's again optimized around driving. We really have a really clear goal. In our past life, we had a consultancy and we worked for many of the big OEMs, and I was always in awe of the difficult challenge that some of these companies have. I mean, if you imagine your Porsche designing the 911, it might be driven by someone taking the kids to school one day, and the next day somebody else might be taking it to the Nürburgring, and that's a really difficult thing to try and balance, and quite how they make decisions about how far they go in each direction. We don't have that problem. We're just trying to reduce weight, we're trying to reposition the weight, we're trying to reduce drag, we're just trying to make the product more efficient. So this is a wheel we launched on the car back in 2016, and later optimized with Autodesk using Fusion 360. It was a collaboration project we did. So this is a carbon hybrid wheel. So the center is a forged aluminium center that's machined from solid, but the rim is carbon fiber. The most important place to save weight on the car is the tire, and after that it's the wheel rim. After that it's the center of the wheel and the disc and the things like that. So we launched that wheel in 2016, and then as we iterated it using Fusion 360 and generative design, we optimized it. We saved an additional kilogram out of the center. What was really interesting about this part of the project, if you look top right, we were able to see fairly quickly what is the optimum. Now, it turned out that the optimum looks like Swiss cheese, be unpayable at the moment with the cost of 3D printing in metal, but it did give us a sense of this is how far it's possible to go. And so we saw we had just under a 2 kilogram optimization was possible, but that by iterating the design, confining the software to give us 5-axis and 3-axis machinable solutions, we were able to get with a 1.2 kilogram saving. So in the past, when you've been doing FEM and then you'll try it again and you'll iterate it, you're never really sure how long do I keep iterating and how far can I really go? I'm going to get less and less return as I develop. How far can I go? Whereas having that vision of how far you could go was really helpful, and it meant that once we could get something that was almost cost neutral and had a 1.2 kilogram saving, that was holy grail for us. This is a 4 kilogram wheel, it's the lightest in the world. Another interesting aspect, on the left you see what the generative design software kicks out. We're not at a point right now where we're able to simply put that on the car. There's aesthetic considerations, there are some manufacturing considerations, and there's the way the rest of the car looks. And so what we're still doing at the moment is we're taking that as a guide and then using that generative design to guide us to optimize the design. As I said earlier, we want to reduce weight. Once we've reduced it, we want to lower it as far as we can in the car. Once we get it on the floor, we want to bring it to the center line. And once it's on the center line, we want to try and get it to the driver. In an ideal world, we'd have all the mass would be in the driver and the rest of the car would weigh nothing, which is obviously impossible, but that's the goal we're trying to work towards. So, for example, this is an X-ray image done with VRED. Originally, the battery was in the front because it allowed us to put it on the floor. It was a lead-acid battery, quite small, stood up, can't lie it down because it's lead-acid. So then we went to a lithium-ion battery. We were able to lie it down on the floor, get it even lower. Once we had it on the floor, we moved it back, and now it's below the driver's legs. So again, bringing that mass all towards the center. Another benefit of the single seat is the frontal area. Despite the fact that we have to cover the wheels and tyres for road legality reasons, we still want to keep the vehicle as aerodynamic and as sleek as possible. So one of the things that's always appealed to me was, if you imagine the silhouette of a driver, effectively everything in the car, apart from the wheels, they're the things you've got to have. We try and put everything in front or behind the driver. We try and put everything in front or behind the wheels. So you end up with, you're not increasing your frontal area, because drag is the frontal area times your drag coefficient, and that's what gives you the force against which your engine has to fight. And so that's another benefit of this focused approach, focused onto a vehicle which is about driving as a leisure activity, not about transport. And what does that deliver? We did an event at the Red Bull Ring late last year. All the manufacturers were there, all from Pirelli, all on the same tyres, Pirelli Trofeo R, and the previous record had been held by the Ferrari LaFerrari, £2.5 million hypercar, and we went 6 seconds faster. Not because we're better than Ferrari, not because we're cleverer than them, but because their product has a legacy of being transport. Their product has space for luggage, it has space for other things. It's trying to do lots of things and does all of them fairly well. We're creating something that's just about driving. I mentioned earlier about optimization, because we make a very low volume. That does limit you to some of the things you can do. You can't really justify the cost for injection molding tools, press tools, things like that. But we're able to turn that around into a benefit. So, if this is a shear plate, so I'll show you in a second where that, in fact, that's where that is. It's in the footwell, just in front of the pedals, which are also all billet machined. If that was any other manufacturer, they'd make a press tool or a casting. It would cost a few pounds, would be fairly heavy, but they could make lots of them. They could make lots of them quickly. For us, we machine it out as solid. It's an expensive part, but what we end up with is a part that is the most optimized it can be. The customer gets the best part possible. We get a part that we can change. We order these parts in batches of 5s and 10s. I think there's nearly 400 billet parts in the car in total. We order them in batches of 5 or 10, and if there's a new function we need to add strength, we found a way to save weight. We're able to delete a bracket and take that function with this part. Then we're able to just change the CAD model, and the next set of parts that we get are updated. Had we invested in tooling, which you have to in some parts, but had we invested in tooling, we'd be much more limited. So that's just another example. And this kind of high piece price, low investment has meant that we've been able to make use of 3D printing a lot in the car. It was interesting hearing the previous presentation, because for me in the early days when I thought of it as rapid prototyping, it kind of limited my own thinking. I wondered, do we make enough prototypes to really justify it? Whereas once I started thinking of it as a way to create plastic parts for the production car without tooling, without injection tooling costs, then all the ideas started to kind of generate from that. So what you see here, this is all the printed parts in the car. So the blue parts are printed on a HP machine from PA12. They're non-structural parts, so they're trim parts around headlights, they're the mirrors, some parts on the steering wheel, which I'll show you later. Bracketry, little parts that hold sensors, little parts that send some of the cable routing. With a solid mounted engine, we do struggle that all that vibration can cause problems for the wiring system in the car. So we have to make sure we support it and hold it everywhere. If anything can vibrate, it'll work hard and eventually it'll fracture. The parts we're kind of most proud of are the Novamid CF10. It's a carbon fiber filled nylon. You see the inlet runners, the red inlet runners on the left side of the engine. They're structural parts. They support the airbox. I'll show you a picture of that later. And they're bolted directly to the engine. They're their engine components that we're now printing. Some deflectors, which take stop stone chips. The mirror arms, which need to be very stiff. So that's just another image showing those parts. So the person who buys our car, he goes through what we call our bespoke process. It's his car. Nobody else is going to drive it. Doesn't have any passengers. It's very much focused around him. And so we go through a process where we sit with the customer, talk about the things he likes. Very much we're trying to find the things he doesn't like, and it's very interesting to see in different parts of the world how the Asians tend to see their car and how they want to kind of configure their car compared to Americans, for example. But what we do is we go through mood boards with them and we try and understand, oh, I like that, or I don't like that, or I find that too flashy, or I find that a little bit too tame or too much. And we start a process where we start a kind of a consultation with the customer. This one shown here, for example, was a customer who's a fan of the original Wipeout game from the 90s. We ended up working with Sony and getting permission to use all the logos. So as you go through that process with the customer, they'll get images, they'll give us feedback, and this is a kind of a two-way process. This is something that's also improved since COVID, I have to say, because I think we've all become comfortable just talking on Teams and video conferencing. And once the design's signed off, the car goes into production. Just as an aside, you can see quite well here that the frontal area, this arrow shape in the middle of the car, although the car is the width of a car and there's bodywork which covers the wheels, the route for the air through the vehicle is very much optimized. But anyway, so the unique paint scheme, however the customers decided to do it. The seat is molded to the driver, so this is really is a made-to-measure car. The seat's molded to you, the pedals are fitted to you, the angle of the pedals, the position of your heel, the position, the spacing of the pedal pads, the steering wheel itself. We mold the steering wheel with clay whilst you're sitting in the vehicle with your arms at the correct angle. The clay's warm for anyone who's had experience of it. It's the modelling clay we use to make the clay models. And once it cools down, it becomes hard and we can modify it, and you can try it with gloves, you can try it without gloves. You've got to sit still for half an hour anyway once the seat's being cast. So that's something else we do, and that's an example of a finished wheel. So that top section is a carbon wrapped 3D printed part. Once we have the clay, we scan the clay, we make a CAD model obviously, and we 3D print that as well, and we give the customer a choice of the shore hardness of the rubber. So it really is bespoke. So that was the finished version of that particular car. 250 permissions to use copyrighted images from Sony to be able to do that, and literally hundreds of hours of masking. It's all paint. There's no transfers, nothing. So in the past, that process worked fairly well. These are just some examples of how that process worked. These are non-ray traced images. And the customer got a fairly decent idea. These are stock environments. A customer got a fairly decent impression of what his finished car was going to look like. But what we've been able to do with improvements in both the software side with VRED and with Z by HP, with the power we can now turn to it. Sorry, what I wanted to just add, then the customer would ultimately would end up with a PDF which he could give approval to or give us feedback from. So that process today has improved. Let's see if this works. It does. So now we're able to ray trace, which allows us to do night scenes. We can do animations. And it's no exaggeration. It was taking us overnight to do a handful of images in the past. And now with these latest machines, we're able to do what was taking 7-8 hours. We're doing it in 7 or 8 minutes. And there's more on the way, which we're excited about. And what that allows you to do is just create higher quality images. And the less we expect the customer to imagine what he's going to get, the better it is. They're not designers usually. And so just showing the effect. Mono's very much about its contrast. So the gloss main body, the matte carbon lower body, and these different textures, you can see them far more clearly now with these ray traced images. I mean, ray tracing is nothing new, but the fact that it took so long in the past just meant it was a bit cumbersome. The way glass can be portrayed, reflections, again, like I say, night scenes. This customer wanted his car to glow in the dark, so you can imagine he was an American. No disrespect. the dash. Again, just showing more realistic images of what his car's going to look like, and that's always the goal, obviously. So they have to imagine less and see more. Here's just some more images. We're now creating our own environments to give them a better feel for what the car looks like out in sunlight. And every car is unique. 70–80% of the cars we do now go through this process. See the level of realism in the tyres, in the brake discs, and the finishes between a powder coat finish and a paint finish. I won't dwell too long on these. I'll probably put too many of these in. Apologies. It's car porn for those that like it. And at the end, you know, the customer will get a video, he'll get images, he'll give us feedback, and eventually he'll sign off. But the future for us, the future that we're really looking forward to, is if they can come to the factory, which has not been possible for the last couple of years, but if they can come to the factory, we want to start them to stand them in the studio and see their car in VR. That's something we'd really like to get better at. It's something we can do right now with the VR headsets from HP. But it's something that we'd like to do more of and improve upon. Something that we've literally just started to do, and something that we're excited about, working again with the guys from Z from HP and NVIDIA. What we'd like to do is eventually you'll get a file to your iPad. You'll log into an Amazon web server, walk out onto your drive, and you'll see your car sitting on your drive. I mean, that's what we want to be. We want him to see it in his garage, in his driveway. We want to see it in his environment. So that's the next step for us. A project we've already started, but is really in its infancy. So I'm often asked, you know, what's next for BAC? This is the graph, the kind of diagram that I mentioned earlier. And just for reference, the area we see ourselves is probably a bit of a scaling problem here. It's a very, very small niche, this top right area of the graph, where it's really nothing to do with transport and all about performance and driving as a leisure activity. That's where we see ourselves moving. These are the types of products we could imagine. We definitely see the broadening of the appeal of the product. There are people who tend to use it mostly on the road, like there's guys with motorbikes who ride mostly on the road, but there's other guys who ride it mostly on the track, and there's everything in between. And so one of the things we want to do is really broaden the product appeal in that respect. Even higher performance versions purely for the track, or some that are a bit more suited to, you know, a weekend in the Alps. And we also see off-road as being a future playground as well. Again, for driving as a leisure activity, nothing to do with transport. Those two areas we see as being the future. Obviously, it wouldn't be complete, any kind of presentation about what we plan to do in the future without mentioning electric drive. We did a study a few years ago looking at battery electric, pure battery electric. We ended up with a weight, unsurprisingly, of a Formula E car, which is the electric racing cars, about 900 kilos, which isn't far off double the weight of the current car. So that kills the product straight away from a dynamic point of view. They just about managed to do a 30-minute race, which is not a product that we can really viably sell. You'd arrive at the racetrack if it was within half an hour away. With a flat battery, with probably very little chance to charge. So we started looking at other methods, and we were able to work with Bosch on this fuel cell version. We got the weight down to 660, I think it was, 655. So we had about a 100 kilogram weight penalty compared to the original car, which still makes me cry. But it's within the realms of possibility. It still uses a battery, but the battery is much smaller, and the fuel cell works in conjunction with the battery. So when you accelerate full power, you get everything from the fuel cell and the battery. And when you brake, the fuel cell recharges the battery, and the regenerative braking charges the battery. It's four-wheel drive to make best use of the driven front wheels for regenerative. And in our simulations, we're actually lapping Silverstone, I think nearly 2 seconds faster than the standard car. So We've lost some dynamic ability with the 100 kilos, but we've gained that back with the traction and the torque. So that is a product that we see potentially a viable product. Of course, today you can't buy hydrogen in very many places, so it's really about positioning BAC to be ready for whichever technology really wins that battle, the availability of hydrogen or the efficiency, energy density of batteries. So that's kind of considered to be our next step, and certainly what we plan to do as far as an E-mono. And that's it for me. Thank you very much, everyone.